ever get that itch, to just stretch your
Yeah,
legs.
absolutely.
Well, today we're talking about stretching the wings of a glider, going way beyond just, you know, puttering around the local airfield and venturing into, well, what is cross-country soaring?
That's it. It's a whole different ballgame. Think about it like this. A local flight, it's like a nice afternoon stroll,
Yeah.
but cross country, that's like a multi-day hike through the wilderness.
Oh,
You need a
wow.
different level of preparation, skill, understanding of the environment. Everything's different.
And that's exactly what we're diving into today, right? We've got
Yeah.
this awesome material here. It really lays out all the essential elements, the things a pilot needs to understand, like really get their head around before they even think about, pointing that glider towards some far off horizon.
Yeah.
So consider this our deep dives. We're
Yeah.
giving you the foundation for a confident and safe cross-country glider flight.
And it's not a casual decision. It's not just, oh, I'm going to go fly 300 miles today.
Right.
You really got to have those fundamentals down, Pat.
Okay, so let's unpack this a bit. What kind of skills are absolutely non-negotiable before someone even thinks about a cross-country?
So the very first thing, like the most important skill, is consistent thermaling ability. You need to be that pilot who can reliably find those invisible elevators, those thermals, columns of warm air rising from the sun-heated ground, and you got to be able to stay in them, work them for a good amount of time. The material, it suggests having a bunch of flights, at least a few over 2 hours.
Okay.
That's a pretty good sign that you've got a knack for working thermals.
So you can actually stay aloft.
Yeah, and that's the key, right? Cross country isn't just about staying up. It's about using those climbs as fuel
I see.
to get you across the country.
So it's like you're using the air itself to kind of propel you forward.
Exactly.
That makes total sense. But what happens when you're out there, you're way out there, and that lift disappears?
That's where perfected short field landing skills come in. They're absolutely critical. That's just the reality of cross country. You might find yourself needing to land somewhere that isn't an airport.
Right.
It's a real possibility. So being like really good at getting down safely, even in a tight spot, that's non-negotiable.
Oh, man. That makes me nervous just thinking about it, being used to these nice, long, smooth runways.
Yeah.
So how do pilots prepare for that? I mean, how do you get ready for something like that?
Well, the material, it really emphasizes practicing simulated off-field landings. You can do this at airports or glider ports. You pick a spot, treat it as your pretend landing zone. And doing this with an instructor, especially at first, that's super important.
Right.
They can give you tips. They can watch you, give you feedback on your approach, your technique, that kind of thing.
Right. So it's about building that confidence, like I can do this even if I'm out there by myself.
Exactly. Yeah. And, the text even talks about practicing these landings without relying on your altimeter.
Wow.
Which can be a bit scary, but it forces you to judge your approach based only on what you see, which is exactly what you'd need to do in a real off-field situation.
Oh, wow.
But one really crucial point, you have to make sure you're not messing with any of the normal air traffic.
Of course. Yeah.
Safety first, always.
Absolutely.
Mm-hmm.
So we've got, okay, we can stay up, we can get down safely in a pinch.
Mm-hmm.
What's the next piece of this cross-country puzzle?
Airspace. You gotta know airspace. Think of it like the sky has these lanes and intersections, like our roads.
Yeah.
Each one's got its own rules, You really got to understand the airspace along your planned route.
Right.
And that means knowing the different classes, there's B, C, D, E, and G, and what the rules are for each one. Think of it as being a good citizen of the sky.
Right.
Knowing the rules isn't just about avoiding getting in trouble. It's about keeping everybody safe.
Oh, for sure.
And making sure your flight is predictable to other pilots.
Right. So it's like a layered cake of regulations up there.
Mm-hmm.
Just thinking about it makes me a little overwhelmed.
Yeah, it can be. You also need to know about the restricted areas, the prohibited areas.
Right.
And the MOAs, the military operations areas.
Yeah.
You need to know when those are active, what it means for you, and, airways too.
Okay.
You got to understand, are there airways near my route, and how might those affect my flight?
So how do you even begin to wrap your head around all that? I mean, it sounds like a lot to keep track of when you're also trying to fly a glider.
Well, that's where the sectional chart comes in. This is your roadmap, your detailed roadmap of the sky.
Right.
The material It really emphasizes ground study.
No.
Like, spend some time, really get to know these charts. It even suggests doing, like, virtual cross-country flights.
Was that like a simulator?
Well, kind of, yeah. You trace the routes on the chart. You mentally fly them, from your local soaring site. Helps you visualize the terrain, the airspace, all that stuff.
It's like doing your homework before a road trip.
Exactly.
But with much more interesting symbols on the map, I bet.
Yeah, so many symbols.
Okay, so what are the specific things that a pilot should be looking for
Yeah.
when they're studying those charts? Like, what are the key things?
Well, there are some key questions, right? Like, can you answer these?
Right.
Where are the airports along your route?
Okay.
Are any of them towered airports? What do all the numbers and symbols mean?
Yeah, there are a lot of those.
So many symbols. Like, what's the runway length? What's the elevation? What frequencies do I need? And then, all the other symbols on the chart. Like,
Right.
what are the airspace boundaries? Where are the navigation aids?
Right.
Where are the mountains and valleys? It's a lot of information.
It's not just pretty colors on a map.
No, not at all.
Okay, so what about technology, like the GPS?
Oh, yeah.
Is that kind of a magic bullet for all of this?
GPS is great. It really is. It gives you like a much better sense of where you are, especially after, an off-field landing.
Okay.
But the material, it emphasizes that you still got to know how to do it the old school way with a sectional chart as a backup.
Right.
Electronics can fail, batteries can die.
Mm.
So being able to pinpoint your location on a paper chart, that's a crucial skill.
Right. So even in our high-tech world, those old school skills are still important.
Yeah, for sure.
Makes sense. Now, we talked about preparing for those off-field landings.
Yeah.
Is there more to it than just being able to, land in a short field?
Yeah, there's more. The material, it talks about site selection training.
Okay.
This isn't just about being able to like land in a tiny space. It's about being able to look out from the air, and pick a safe spot to land.
I see.
And this training, it often involves using self-launching gliders or even powered aircraft.
Okay.
So you can like practice approaching different potential landing sites, in a shorter amount of time.
So you can get more practice in.
Exactly.
Okay. So we've got the skills. We've got the airspace knowledge.
Mm.
What about before the flight even begins? What kind of prep is absolutely paramount for cross-country?
That's where pre-flight preparation comes in. It's so important. This is where the rubber meets the runway,
Right.
And it means you got to think about logistics. What if you have to do an off-field landing? Is your trailer and tow vehicle ready to go?
Right.
Do you have a communication plan with your retrieval crew?
Oh, yeah, that's important.
Super important. You don't want to be stuck in the middle of nowhere with no way to get your glider back.
Yeah, that would not be a fun souvenir.
No, not at all.
Okay, what about weather?
Yeah.
I mean, that has got to be a huge factor when you're planning to be up in the air for hours and hours, covering, potentially hundreds of miles.
It's everything. You got to get a standard weather briefing.
Okay.
But also, and this is really important, a specific soaring forecast.
Yeah.
From, the official sources.
Okay, so what's the difference between those two?
So a standard briefing, that gives you the big picture.
Okay.
It's the general weather along your route. Any NOTAMs, those are like important updates, like if a runway is closed or a navigation aid is out of service.
Right.
And airmets, SIGMETs, winds aloft, information about fronts that are moving through, any areas with potential thunderstorms. It's the broad overview.
So it's like the 30,000-foot view.
Exactly.
And the soaring forecast. That's more like for us glider pilots specifically.
Exactly. Yeah. It's more specialized. It's really dialed in. The material, it explains that these are usually issued once a day by specific National Weather Service weather forecast offices. They're based on data from radiosones. Those are the weather balloons.
Okay.
They carry instruments up into the atmosphere, measure temperature, humidity, wind, or sometimes they use computer models.
Okay.
And the sample forecast, it's from Salt Lake City. It gives you a really good example of the kind of information you can expect.
So, like, what kind of things are in there that would make a glider pilot excited?
Oh, all sorts of goodies. Like the thermal soaring index.
Okay.
That tells you how good the thermals might be.
Right.
The maximum rate of lift you can expect.
Okay.
The max height those thermals might reach. They even have a trigger temperature.
What's that?
That's the surface temperature that's needed for thermals to start forming.
Oh, wow. That's incredibly specific.
It is. And, it also talks about things like overdevelopment.
Okay.
That's when the clouds get too thick and they start to shade the ground, which can really kill the thermals.
Makes sense.
Information on middle and high clouds, surface winds, even the height of what they call the NACS-3 thermal index.
What's that?
It's an indicator of, how good the thermal activity might be, especially for cross country. And then, they even give a thermal soaring outlook for the next day.
So it's like a weather forecast specifically designed to help you find lift.
That's exactly it, yeah.
I noticed they also mentioned something called the K index. What is that?
The K index. That's
Yeah.
a measure of atmospheric stability. It combines a bunch of factors like temperature differences at different altitudes, moisture levels, stuff like that.
Okay.
Think of it as a weather mood ring for soaring.
The mood ring. Okay.
Higher positive numbers, that means the atmosphere is energetic, more likely to produce good lift, but also a higher chance of storms.
Oh, okay.
And the material, it even has a table that kind of interprets those K index values
Right.
and what they mean for soaring conditions, specifically in the western U.S.
Cool.
So low negative values, that means weak or no thermals. High positive values, good to excellent soaring. But, if it's really high, then the chance of showers and thunderstorms, that goes up too.
So it's like a little bit of risk, a little bit of reward.
Yeah, that's a good way to put it.
Okay, so you got the general weather, you've got the super specific soaring weather. What else goes into, actually finalizing those flight plans?
Well, the material, it really emphasizes pre-planning.
Okay.
Multiple options, especially if you're aiming for a closed course flight, like a 300 nautical mile triangle.
Right.
Having a couple of potential routes mapped out, that lets you pick the best one on the day,
Yeah.
Based on the actual weather, the forecast, and also, thinking about all the stuff you need for the flight the day before.
Yeah, okay.
So you don't have to rush around last minute.
Yeah, I see. So you're not, running around like a chicken with his head cut off trying to find everything.
Exactly, yeah.
Okay, so it sounds like they're really trying to drill home this idea of not rushing.
Yeah.
Because nothing good ever comes from rushing in aviation, it seems.
No, it doesn't. And, lack of preparation, that leads to delays.
Right.
And delays, they eat into your soaring time.
Yeah.
But even worse, if you're rushing, you might overlook a really important safety item.
Oh, yeah, for sure.
That's why they recommend using checklists for, every phase of your cross-country preparation.
The checklist, a pilot's best friend. So what kind of things would be on those cross-country specific checklists?
Oh, everything. What to take to the glider port,
Okay.
food, water, charts, your barograph, all that stuff.
Okay.
And then the assembly procedures.
Right.
Those are laid out in your glider flight manual or, the pilot's operating handbook.
Mhm.
And then you'd have checklists for, making sure you have positive control of the aircraft, pre-launch items, like making sure you've got your charts where you can reach them, your barograph is on, your oxygen is checked.
Okay.
Don't forget the briefings for your tow pilot, ground crew, and really important, your retrieval crew.
Yeah, they need to know what's going on too.
Absolutely, yeah. And then, of course, the standard pre-takeoff checklist.
Right.
Being organized before you go, it reduces stress and it keeps you safe.
Right. Reduces the chance of something going wrong.
Exactly.
Okay, so the planning's done. The weather looks good. What essential equipment does a pilot need to have on board for one of these cross-country adventures?
Well, beyond the usual, the flight instruments, stuff like that,
Yeah.
there's personal equipment and special equipment that becomes really important for these longer flights.
Well,
Pilot comfort is important. You got to have enough drinking water.
stay hydrated.
Yeah, dehydration, that can really mess you up. The material, it even mentions backpack drinking systems, with the hose, so you can easily take a sip.
Oh, yeah. I've seen those.
And don't forget food. These flights can go on for hours.
Yeah, for sure.
And then for those really long flights, you might even need a relief system.
Right, nature calls.
Yeah, exactly.
Okay, so what about safety gear for those potential off-field landings that we talked about? Like if you have to put down somewhere unexpected.
Yeah, you got to have a land-out kit. That's essential. This should include a way to secure your glider once you've landed. Okay.
And, depending on the area, you might need extra water, extra food, especially if you're, far from roads
Right.
or any kind of help.
Right.
Walking shoes, those could be really helpful if you got to hike to get help. And, a cell phone, if you have service, that's a must.
Yeah.
And then For more remote areas, some pilots carry an EPRB, an emergency position indicating radio beacon.
Right. So if you're really out there,
Yeah, you got to be prepared for anything.
that makes sense. It's about self-sufficiency if you end up somewhere you didn't plan to be. Okay, what about navigating once you're up in the air? I
Yeah.
mean, we talked about sectional charts, but what are some of the other tools to help you stay on course?
Well, there's GPS systems, of course.
Yeah.
Those measure your distance, and then there are the traditional tools like a plotter.
Okay.
You use that with the paper chart.
Mhm.
And then, glide calculation tools. Those are really
Right.
important.
They help you figure out how far you can glide from your current altitude given the wind conditions and the performance of your glider. Every glider has a performance polar.
Okay.
That's like a chart that shows how efficiently it can glide at different speeds. It's kind of like knowing your car's fuel efficiency at different speeds.
So it's not just a simple straight line, okay, I'm this high, I can go that far kind of thing. Wind must play a huge role.
It does, yeah. Headwinds, those reduce your gliding distance.
Good.
Tailwinds increase it. And the glide calculators, whether they're simple tables or circular mechanical devices or, fancy electronic glide computers, they all take that performance polar into account.
I see.
And the material, it even has an example of how to calculate your effective lift-to-drag ratio. That's the LD,
Okay.
when you have a headwind or a tailwind.
That's interesting.
Yeah, and understanding how wind affects your efficiency, that's crucial for good planning.
So a strong headwind can really mess up your plans.
Oh yeah, for sure. It can turn what seems like an easy glide into something really risky.
Okay. And what about when you're up in the air, you're encountering, rising air, sinking air? How do you figure out what speed to fly at to, cover the most ground?
That's where a flight computer or a McCready ring comes in.
Okay.
Those help you determine the best speed to fly at, to cover the most ground given the sink rate you're in.
Okay.
A lot of the electronic ones, they even have audio cues so you can keep your eyes outside.
Oh, cool.
But, like anything else, it's good to have a manual backup in case those fail.
Right, of course.
And the idea behind McCready theory, it's all about strategy.
Okay.
You're trading a little bit of altitude now so you can get to a potentially stronger thermal faster.
Oh, interesting.
It's about thinking ahead.
So you're making these strategic decisions in the air based on what you think is coming.
That's right.
Cool.
And any other gadgets that a pilot might find useful?
Yeah. What else is in that cockpit?
Well, for pilots who are going for FAI badges, those are from the Fédération Aéronautique Internationale, or, if you just want to record your flights.
Right.
They use equipment like turn-point cameras, barographs, those record your altitude, and GPS flight recorders
Okay.
to, verify their performance.
Right. To prove they did it.
Exactly.
Yeah.
And, something as simple as a notepad or a knee board,
Yeah.
that's still a really useful tool.
For writing stuff down?
Yeah, you can jot down weather forecasts, turn point distances, and then when you're in flight, you can write down your takeoff time, turn point times, any changes to your plan.
So a well-equipped glider cockpit sounds like a pretty busy place.
It can be, yeah.
Okay. Now let's talk about actual navigation.
Right.
Like how is glider navigation different from the way an airplane pilot might typically navigate from point A to point B?
Airplane pilots, they often use both pilotage and dead reckoning.
Okay.
Pilotage is like navigating by looking at landmarks on the ground. And dead reckoning, that's calculating a heading based on your airspeed, the wind, and how long you've been flying.
Okay.
But glider pilots, we tend to rely more on pilotage.
Why is that?
Well, because we often deviate from a straight line. We're chasing lift,
Right.
and our speed isn't constant like a powered aircraft.
Right. You're going up and down.
Yeah, exactly. But, sometimes we use dead reckoning, too.
Okay.
It depends on the situation.
So it's kind of a hybrid approach.
Yeah, you could say that.
Okay. So let's make this a little more concrete. The material, it has this example, cross-country flight.
Oh, yeah.
Could you walk us through what that might look like from a navigation perspective?
Sure. So this example, it's a triangle course. You start at Portales Airport,
Right.
go to Bender Airport, then to circle back, which is a town, and then back to Portales.
Got it.
So before you even go, you draw these course lines on your sectional chart.
Okay.
You can do it electronically or, on paper. And in this example, the forecast says cumulus space is 11,000 feet MSL. And they give you winds aloft at different altitudes.
Okay.
So, the pilot, they note how those winds will affect each leg, crosswind on the first leg, weaker crosswind on the second, headwind on the final leg.
So you're already thinking about how the wind's going to impact you.
Yeah, and you might even decide to fly the course backwards, depending on what the winds are doing.
Oh, wow. So you're already adjusting your plan before you even take off.
Yeah, exactly.
That's cool.
It's all about having that mental picture, of your route, the environment,
Right.
even before you leave the ground.
Okay, so what happens once you're actually up in the air?
Well, you're looking for those landmarks, those alternate landing sites.
Right.
So, like on that first leg, the route follows a highway. It goes parallel to some railroad tracks past the town of Clovis.
Okay.
And the pilot, they're thinking about, okay, there's Class D airspace around Cannon Air Force Base.
Right.
If I deviate for lift, am I going to run into traffic that's going into the base?
Okay.
That kind of thing.
So you're thinking about those things as you go.
Yeah, constantly. And then, as you keep flying, you use those visual landmarks.
Okay.
Clovis Airport, the towns of Bovina, Friona, the Texaco VOR, all that stuff helps you stay oriented.
So it's really like you're looking out the window and you're comparing what you see to what's on your chart.
Yeah, exactly.
Okay, what about what if you need to deviate from your planned course?
Yeah, that happens all the time.
Really?
Oh, yeah. It's almost expected on a cross-country flight.
Yeah.
Even if it's, a perfect day, beautiful clouds, you might still deviate towards an area that has better lift.
Right.
And, small deviations like 10 degrees or less, those don't add much to your total distance.
Right.
And they're often worth it if the lift is better.
So it's a trade-off.
Yeah. And even bigger deviations up to 30 degrees, those could be worthwhile too. If they get you to much stronger thermals, or they help you avoid an area where you think there might be sink,
Okay.
the key is to start your deviation early.
Oh, I see.
So you don't add too much extra distance.
So you're constantly looking at the sky ahead and you're making these decisions about where the best lift might be.
Yeah, exactly.
Oh.
And, sometimes the weather can change.
Right.
In the example on that second leg, the weather starts to deteriorate up ahead.
Oh, no.
Yeah, so instead of continuing, the pilot decides to cut the triangle short.
Okay.
Fly directly back to Portus.
Right.
But that means estimating your new distance, your new heading, accounting for wind, all that stuff.
Wow. So it's a lot of calculations on the fly.
It is, yeah.
How does GPS, how does that technology impact this decision-making and the navigation?
Well, GPS makes navigation a lot easier. It'll show you your distance and heading to a point.
Okay.
You can often pick that point from a database of waypoints. And, a lot of them, they're constantly calculating your ground speed.
Oh, cool.
They can even give you headwind information.
Wow, that's amazing.
It is, but the material, it emphasizes that you still got to fly the glider.
Right.
You got to be looking for lifts, scanning for traffic, and, you always got to have a backup navigation method just in case your GPS fails.
Right, of course, yeah. So TPS is this fantastic aid,
Absolutely.
but it doesn't replace the fundamental skills.
No, not at all.
Okay. So we've got the planning down. We know how to navigate. What are some of the key techniques that a pilot needs to really master for successful cross-country soaring?
The most important thing is to always stay within gliding distance of a safe landing spot.
Okay.
Whether it's an airport or a field you've picked out in advance, you always got to have a place you can get to if you need to.
Right, that makes sense.
And the material, it recommends practicing cross-country techniques on short triangle courses.
Yep.
Near your home airport before you go venturing out further.
So it's like a stepping stone.
Yeah, exactly.
Okay.
It's a great way to build up your confidence, get a feel for things without, the higher stakes of a really long flight.
So what kind of things should you be practicing on those shorter flights?
Well, these practice courses, they're usually pretty short, like 5 to 10 miles per leg.
Okay.
Depends on the glider. They let you practice things like switching communication frequencies.
Okay.
Listening to the air traffic at the nearby airports.
Right.
And, really important, regularly checking the altitude you need to get back to your home airport.
Okay.
And setting a minimum arrival altitude, as a safety margin.
Right, just in case.
And, every single soaring flight should end with an accuracy landing.
Right.
You got to keep those skills sharp.
Right. What about getting a feel for what the wind is doing up there?
Yeah.
How do you gauge that without, fancy instruments?
There are a few ways. Some flight computers, they'll calculate it for you automatically. And GPS systems, they can estimate it based on your drift during thermal turns.
Okay.